A controversial study suggests that introducing microbes into the subsurface ocean of Enceladus could pave the way for the colonization of other worlds. Injecting terrestrial microbes into icy, distant moon oceans may seem like the evil scheme of a supervillain in comic books. However, researchers argue that, given the potential for liquid oceans beneath the surface of places like Enceladus, Titan, or Europa, all moons of Saturn or Jupiter, now is a fitting time to seriously consider the idea of seeding a world with life. Charles Cockle, an astrobiologist at the University of Edinburgh in Scotland, asks, could this process be humanity's first experiment in creating a biosphere? Cockle and his colleagues, in a study published in the journal Space Policy, say that Enceladus, a moon of Saturn, could be the best place to start any inquiries about seeding an alien world with life because it appears to have all the necessary ingredients for the type of life we know. However, the very idea of injecting life as a form of experiment raises many ethical and practical questions. How can we ensure that there is no existing life there? And will we potentially disrupt the evolution of an alien ecosystem? What kinds of experiments do we want to conduct? And what answers will these experiments provide us? Most of what we know about the small moon of Saturn comes from NASA's Cassini spacecraft. This probe studied Saturn from 2004 to 2017 and also orbited many of its moons during that time. Notable discoveries from the Cassini spacecraft include plumes of water vapor and ice that were regularly ejected from Enceladus's south pole. Scientists believe that these eruptions are the source of the snow that covers the surface of this moon, making Enceladus the brightest object in the solar system. Subsequent flybys of the spacecraft revealed that the material expelled from this moon includes elements such as nitrogen, carbon, sulfur, hydrogen, and phosphorus. Cockle states, these geysers contain all the essential elements needed for life. Additionally, scientists believe that the geysers of Enceladus are likely fed by a subsurface ocean. Cockle notes that although the materials emerging from these vents may not originate directly from that ocean, it is still possible that it could support life. However, it is possible that life already exists there, posing a significant ethical dilemma in any discussion about injecting Earth life into other worlds. Ideally, a celestial body chosen for seeding should be habitable yet uninhabited. If there is already indigenous life present, any intervention might severely disrupt the ecosystem. Our own planet is full of examples of failed seeding experiments. For instance, mongoose, Asian palm civets, were introduced to the Caribbean islands to control rat populations but quickly became uncontrollable, causing extensive harm to native ecosystems in places like Jamaica and Trinidad. Cane toads were also introduced from Central and South America to Australia, Hawaii, and other areas to manage agricultural pests, but ended up causing significant damage to native predators. Even with tools to definitively detect life on Enceladus, scientists will likely struggle to predict the potential harmful effects of introducing foreign microbes into a fragile extraterrestrial ecosystem. Morgan Cable, a planetary scientist at NASA's Jet Propulsion Laboratory at California Institute of Technology, says, "We have very sensitive tools, but I don't think they're sensitive enough right now to confidently declare that a world is lifeless." Cable believes that until every nook and cranny has been investigated, we cannot assertively say that life does not exist. Although Enceladus is small, approximately the size of Arizona, accomplishing this would still be extraordinarily challenging. There are also some regulations, or at least guidelines, regarding the potential contamination of foreign ecosystems. The Committee on Space Research, COSPER, an international consortium to promote space science, has established specific ethical guidelines regarding the exploration of Enceladus and Europa, a moon of Jupiter that likely also has a subsurface ocean. Any lander wishing to touch down on one of these moons, even for a short time, must be completely sterilized. Since achieving complete sterilization may be impossible, any microbes that survive must have a very low probability of coming into contact with the subsurface ocean in the next 1,000 years. Cable states, "We've set a deadline for ourselves to address potential issues." In other words, if researchers contaminate the surface of Enceladus, they will have 1,000 years to find a way to prevent the contamination from spreading to the subsurface ocean.